Okay guys, welcome back. So in the last video I introduced you about Ohm's law and the basic theories of current electricity or basic electricity, and I introduced you what is meant by the current, what is meant by the potential difference, and how potential difference and the current are related in accordance with the resistance of a circuit, and I introduce you the Ohm's law. So in this video I'll be talking to you about resistors in series. Now in the last video at the last example I took, I introduced you a simple example in which I took a 5 ohm resistor and I connected a 2 volt voltage supply across this resistor, and we found that I is equal to 0.4 amperes. Alright. So I is equal to 0.4 amperes when a 2 volt voltage source is connected across a 5 ohm resistor. Now for most of the problems you get in daily life and also the problems you will get in current electricity, you will not end up meeting a single resistor. Now what if 2 or more resistors are being given and you have to find the system's current? So for that you need to understand two concepts, which are the resistors in series that will be discussed in this video and resistors in parallel, which will be discussed in the next video. So in this video I will be talking about resistors in series. So let's start it. Resistors in series or resistors in series, or series resistors in series. So first of all, before going to some example, I'll derive a simple equation in order to understand, for you to describe what's happening and how we can put up a simple relationship in order to find out the resistance of series, and then we can derive a simple equation and then we can apply to practical problems. Alright, I'll take 3 resistors to be like this. One resistor to be of resistance R1, right? Resistance R1, and another resistor of resistance R2, and another resistor of resistance R3, and as supply a voltage V across this circuit, and let's see what happens. When a current I is flowing through this circuit, since this is the same wire, so that is the important concept. Same wire. This is the important concept. Same wire. The current through this circuit should be the same. The current through this circuit should be the same, regardless whether there are 3 or 4 or 10,000 or n number of, even infinite number of resistors. The current through this circuit should be the same, right? So if a current of I flows through this circuit, the current of I should return to this circuit. Now if this is dry cell, this is a dry cell or a normal like large cell, the current leaving from the cell should receive at the other end. So this is the concept. Alright. Okay. So now, as I mentioned in the last video, there is a potential difference build-up or the voltage build-up, right? A voltage build-up in this video I talked to you. A voltage build-up in this cell due to a current flowing across this resistor. Now what actually happens when you are connecting 3 resistors is that there will be 3 potential differences. One across this circuit, this resistor, which I will take V1, needs to be V1. One across this resistor, I will take it to be V2, and one across this resistor, I will take it to be V3. Alright, so V1, V2 and V3. So we have to find the values of V1, V2 and V3 in order to build up a relationship. So what I will do is I will put Ohm's law to these 3 resistors. Alright, so for the first resistor I can say V equals IR, so V1 equals I times R1, equation number 1. And for the second resistor, V2 equals I times R2, second equation. and for the third resistor V3 equals I times R3, third equation. So what actually happens is that V1 equals IR1, V2 equals IR2 and V3 equals IR3. Now the voltages that are building up in this circuit are due to the voltage that we supplied here, So what actually happens is that without this voltage, there won't be any voltages or any currents through this circuit. So the total voltage is supplied by this circuit, right? This cell or any other voltage source. So the total voltage across this point, these two points, if you take these 2 points should be equal to the total difference or the potential difference across these 2 points, right? The potential difference across these 2 points should be equal to the potential difference across these 2 points. So what actually happens is that V should be equal to V1 plus V2 plus V3, or conversely V1 plus V2 plus V3 should be equal to V, right? So that's evident. So what actually happens is that V1 is equal to IR1, V2 equals IR2 and V3 equals IR3. So we can substitute those values into this. So V equals IR1 plus IR2 plus IR3, right? And if I replace the whole set of resistors by one resistor like this, and I apply the same voltage and the same current, so what actually happens is this, the resistor to be like this and the voltage to be like this and the current to be again I, you can say V equals IR, again from Ohm's law, right? So you can substitute that IR in here. So IR is equal to now IR1 and IR2 and IR3. So I should be not equal to 0. So what actually happens is that I cancels out from both sides, right? So the effective resistance, between these circuits is actually R1 plus R2 plus R3. So R is equal to R1 plus R2 plus R3. So this is a very important relationship. So R is sometimes called EFF because it's the effective resistance. So our effective resistance is equal to R1 plus R2 plus R3. For n number of resistors, REF should be equal to R1 plus R2 plus R3 plus R4, like that up to n. So the effective resistance when the resistors are in series is equal to sigma R equals I to n R I. Right? So this is the general equation we are using for n number of resistors. So when R is equal to 1, from R is equal to 1 to n, when R is equal to 1 to n, right? This is not I. From R equals 1 to n. So when you substitute the value of R effective will be equal to R1. When n is equal to 2, that will be from 1 to 2, so that will be R1 plus R2. From 1 to 3, so that will be R1 plus R2 plus R3, as we have deduced here. And when n is equal to n, it will be R1 plus R2 plus R3 plus up to Rn, the summation. So this is the general equation that we get for resistors in series. Alright, so let's take another example. In order to elaborate this concept. This is a very important concept in this theories of resistance and theories of electricity, because you will get complex systems, complex electric circuits in which you have several resistors, and you have to find the effective resistors, and also you have to find the voltages and currents when you are given some resistors and some other terms. So let's take a simple example. Alright, so I'll take a circuit to be composed like this. This value is 5 ohms, this value is 6 ohms, and this value is 8 ohms, right? And we supply a voltage of 8 volts across this circuit. What I'm asking is, what is the current that is flowing through this circuit? So these equations, these resistors are actually in series, because the same current is flowing through this circuit. So I'll take the value to be I, and in that direction. So what I can say is, there are two ways to find this. Either to find the voltages from the equation that we got, right? So from the way we got V1 equals IR1, then find V1, and then find V2 and find V3, and then equate it to 8 volts and find the value of I, because R1, R2 and R3 are given. But that's somewhat complex, and it is time consuming, and sometimes it leads to some errors, because there are too many calculations, too many steps to be solved, so there may be errors. So it's not a very good method in solving this. So it's very easy from the equation that we have already got. So R effective is equal to sigma from I is equal to 1 to n Ri. So since n is equal to 3, because there are only 3 resistors, R effective, as in the case we described before, R effective will be equal to R1 plus R2 plus R3. So let's calculate R effective first. So we can replace these 3 resistors with a single resistor of resistance R effective. So R1 plus R2 plus R3 is 5 plus 6 plus 8, which is 19 ohms. Right? So this circuit is now similar to this circuit, in which the resistor is 19 ohms and the voltage supplied to this across the ends of this resistor is 8 volts, and we have been asked the value of I. So we can simply put V equals IR, because the potential difference across these 2 points is equal to the potential difference across these 2 points. So V equals IR. So the voltage is 8, and current I will take it as I, and the effective resistance is 19 ohms. So I is equal to 8 by 19 amperes, right? I is equal to 8 by 19 amperes. So I will not solve that. I will not make it decimal into account. So that is the effective how effective resistance plays a key role in finding the voltages and the currents in circuit. So it's very important. So in this video I talked about the resistors in series. So in the next video I will be talking about resistors in parallel, which is equally important as this video, in order to carry out the next theories, or to proceed to the next theories of current electricity. Alright, see you then.